Today I'll be doing LeetCode weekly contest 176, and I'll be explaining my solutions after I solve all of the problems. Cube of the last k numbers. Oh, there might be 0. $32 integer. If num is 0, then let's clear everything. Okay. $803. Compiler. There's no clear method. Accepted. Geo is not declared in this. Oh wait, K is. Oh, K is not fixed. I see. Okay, then. EJS difficulty. All events have length 2. Wait. Oh, never mind. It should be 0. Where's the invoice though? Okay. Guess I'll do a greedy accepted. Actually, while loop from if vi j0 is, let me add this into the map. What do I have to choose one to use? And the length is pretty big. I think you just start from the biggest. The order doesn't matter. Okay. Store in the set. So I store in the map. Time limit exceeded. So I forgot to remove things. This is not unequal to. So look at the largest one, and then S2 is just S minus the sum of the current one. But if they're duplicates, then okay, I'll do this one. If they're duplicates, then the answer is, wait, never mind. That's the sum of the other elements, and then you subtract them. Okay, run code. Oh, I didn't update the sum. True, false, true, okay. Means I can submit. I feel like I'm a bit slow today, like I had a lot of bugs in different places. So time limit exceeded. Maybe it's because I forgot to use, I used an instead of long here. Oh no. Now I have like 20 minutes and 1 penalty. That's not very good. Yeah, I don't think I did very well today. So anyways, I'll start with the explanations. So for the first problem, basically you're given a matrix and then you're also given that sorted in both in its rows and its columns, and then you return the number of negative numbers in the grid, and can basically just ignore this condition because you can just check each element and check if it's negative, and if it is, just add 1 to the answer. And that's basically it. For this, basically notice that it says that at any time the product, so first you need to implement add number, which adds the number to the back of the list, and then get product, which gives the product of the last k numbers. So basically the product won't be too big, so that means that we won't have, if we have a lot of 2's, then after just 32 2's, then we will overflow. So that means in our list we're going to have a lot of 0's and a lot of 1's. So what we can do is, in our list we'll ignore all of the numbers which are equal to 1. Instead, we'll only add the numbers. Yeah, this if statement is unnecessary here. Basically, we'll only add the numbers which aren't 1, and we'll also add their original index in the array. So every time I add a new number, I increment the index. Then when I call get product, I basically start with the product is 0, and then I start from the back of the list. And then since we want the last k elements, basically the index of the last element is int -1, and then the beginning of that is int -k. So while we go through the list, and while the index of the element we're going through is still within the range of the last k elements, then we'll multiply that to the product, and we'll go to the element before that. And then if the product is already 0, then we can just break the array, because it will always be 0 no matter what. So the reason, if you look at the constraints, there will be at most 40,000 operations. The reason this works fast is because the product increases very quickly. If the product increases very quickly when all of these are not 1. So for example, if all of these are just 2, then if you multiply 32 times, then you'll already get over the limit. So this loop actually doesn't execute a lot of times. And then you also need to remember to check if product is 0, because if you don't include this check, then the program might multiply for a long time. So maybe if the array was like this, and if we don't have this check, then our loop will multiply all of these numbers. But then if we do have the check, then our loop will go here, and it will realize the product is 0, and it will stop immediately. And if we do that, if we include that stop, then we can guarantee that this loop will run at most 30 times, because like 2 to the 30 is like just smaller than the limit of a 32-bit integer. For this problem, basically we can do a greedy algorithm. So basically what we'll do is, for day 1, we'll find some event that covers day 1, and we'll basically just check if any intervals cover day 1. But what happens when there are multiple intervals that cover day 1? Then it makes sense to choose the interval which has the smallest end day, because the interval with the smallest end day is going to expire faster. So we'd rather choose the interval with the smaller end day earlier on, in order to and it'll be better than, it'll be at least as good as choosing another interval. So the way I implemented this was using a map. So first I sorted the intervals. So then the intervals I sorted by start day. Then I iterate over all possible days. And then this if statement is for adding new intervals. So if we have an interval such that the start day is smaller than or equal to the current day, then we'll add its end day into the map or the multiset. And then otherwise we'll choose the interval for the current day. And the way you do that is basically we look at the interval with the smallest end day in our multiset, and if that end day is smaller than the current day, that means we can't use it anymore, so we just need to remove it. And then we either keep removing until the list is empty and until our set is empty, or until we finally find an interval which has an end day which is greater than the current day. And if the set is empty, then we just continue. Otherwise, we subtract 1 from the set of the intervals with that end day, and this basically checks if the count is 0, then it'll also remove it from the map. And finally we add 1 to the answer. And yeah, that's pretty much it for this problem. For this problem, notice that basically we'll try to do the operations in reverse. So let's see if we can do this operation on this number. So if we do the operation on reverse, it's basically the same as choosing a number and then finding the sum of all other numbers and subtracting the sum from our current number. So for example, if we choose to do the reverse operation on 9, then we find the sum of 3 and 5, which is 8, and we subtract it from 9, and it becomes 1. And then we can do the reverse operation again for 5. So the sum of the other elements is 4. We subtract it from 5, and we get 1. And we can do it for 3 as well. And basically, the reason we do this reverse operation is that notice that the reverse operation can only be applied to the biggest element in the array. If we apply it to an element which is not the biggest, like 5, then the sum of the other elements must be greater than the element we chose, because there's the 9 here, so the sum must be greater than 5. So if we chose 5, then after we do the reverse operation, 5 will become negative. So the sum of the other elements is 12, so 5 will become negative 7. And then that's impossible because we should never get a number with a negative value. So we should always do this reverse operation on the biggest number. So what we can do is we can maintain a multiset of all the current numbers in the array, and then we'll also keep track of the sum of the numbers we have in our set. And what we do is we first find the biggest number in the array, and then this is the value of the biggest number. And then if the value of the biggest number is 1, that means that all elements are already equal to 1. So that means we don't have to do any more operations, and then we can just return true. Otherwise, we find the sum of the other elements in the array, which is S2. It's just the sum of the elements of all the elements minus the current element. And then we subtract 1 from the occurrence of X. And then we subtract the sum of all the other elements in the array by X. And since x changed, that means the sum will also be changed. And in fact, the sum will also be subtracted by the sum of all of the other elements in the array. And finally, if x is smaller than 1, then we know that we have reached an impossible situation. So in that case, return false. Otherwise, if the sum is greater than, if x turns out to be greater than or equal to 1, then we will add it back into our set. Okay, so this, you know that this is, so now you know that this is correct and that this process will terminate, but how do you know if it's fast enough? Well, you can basically actually the test cases for the test cases for LeetCode are weak. Wait, I think I can actually make my solution fail. I did not handle this case yet. Yeah. Okay, so instead, what I forgot to do here was, so basically, this process will, this one here will be subtracted. The number of operations that can be performed on this test case is actually a lot, since 1 will just be subtracted from this a lot of times. So instead, in order to fix this, basically we can do a lot of single operations at once. So that means we need to find the second largest element in the array. And then basically, instead of using a subtraction, we'll subtract like a multiple of S2 so that I can do this fast enough. But then the largest number will still have to be greater than, yeah, okay, so actually, okay, so we can calculate the number of times we're allowed to subtract S2 from X. Call this C. And then formula is from this. And then we subtract C times S2 from both sums. And if C is 0, then that means that we couldn't do anything, so it means that we can't do any operations, so we should just return 0. Otherwise, we do each operation for C times, and then we add it back in. So now this should work. Yeah, okay. So now this is definitely faster than my previous solution, but I'm not sure of the time complexity yet. Okay, so I think I just thought of it. Okay, so we know that the element we choose is greater than S2. and then the sum of the elements is S2, so we know that sum of array is greater than or equal to 2 times S2. And then oh, I see. Okay, so basically what we're doing here is x becomes the remainder of the previous x and S2. So if we do the remainder operation on a single element, then if the old element was greater than S2, then the old element must be half as big as it was before. This must be less than half as small as it was before. So, for example, if we do an operation on 9 over here, then after one operation, it must be smaller than or equal to 4.5 because we take the remainder. Okay, so this is true because what I'm saying here is that if x is greater than or equal to y, and then x mod of y will be like smaller than or equal to x divided by 2. And so first, this operation is basically the same as taking x mod S2. So now how do we prove this? If x is greater than or equal to 2y, then after we do the modulo operation, x will be smaller than y. So this is true. And then otherwise, x is between y and 2y. And then the new x, so that means the new x over here will be x minus y. And then you want to know if x minus y is smaller than or equal to x2. So we can rearrange the equation and get x2 is smaller than, the equivalent condition is x2 is smaller than or equal to y. But then we already guaranteed this because of our assumption. So that means that this also holds true when x is within this range of y. So how does that prove our time complexity? Each time we perform an operation, some element of the array becomes less than half as big as it was before. So basically the maximum number of operations you can perform on a single element of the array is the log of its initial value. And for the current problem, it's like 30. So let's say maybe you can perform at most 30 operations on a single element of the array. So that means you only perform 30 times n operations on the entire array. So, and 30 times n is good enough for this problem. Each operation takes log n time, so yeah, so it should be fast enough. Okay, not sure if my ranking will change. Change to 13. Okay. Is it 10 or 13? I'm not sure. Oh well. So if you found this video helpful, then it would help to like and subscribe, I guess.